Hi guys, and it's time for another video. Even that is quite hot again here in Vienna, but it will be hot for quite a few weeks further, so I have to live with that. And of course, hot day, a power video, not a high voltage. It is mains level voltage. It will be a tear down, full reverse engineering with schematics and some tips and informations on one of these everywhere seen modules on AliExpress and eBay, Taobao, everywhere. So what is this thing exactly? Well, in reality, it is just a big power oscillator, isolated. The Chinese use these things, or they were intended to be used as pre-stages for inverters, either pure sine inverters or modified sine inverters. If you use a high voltage input, either pure sine or modified sine inverter, you need at least 300 volts on the switches, on the output switches, on the MOSFETs. And this is exactly what these things are intended to do. Here you should have normally a bigger heatsink. They do nothing else. They take 24 or 12 volts. This module is for 24 volts. And they make just a square wave output from the voltages you see here. Either 220 or up to 380. And there is a second winding with 18 volts, an auxiliary winding. I will show you much more informations in a jiffy, in a while. Yeah. The design of these things is crude, very crude. There is no safety at all. Yeah. It's a completely open loop design. That means no feedback in any way. This is why I said just a big power oscillator. And you will think then, okay, yeah, then why you show us that? This thing we have seen this thing before. And it's a toy. No, it's not a toy. Even if it's crude, it has its uses, and I want to show you a few of them and why I'm gonna use it. Well, I'm not going to use this module. I'm going to use part of this module, and you already see what I'm going to use. Yeah, the transformers. As I said in many of my previous videos, I'm not winding transformers. I would wind perhaps a toroid one, a small one, or a chock, but that's it. I'm not winding these transformers. I will calculate them in the worst case, and I will let the winding be done in China. If it is for private reasons, for private projects, or for not commercial projects. And if it is for commercial projects, the transformer will be done in Europe. But there is a lot of stuff on AliExpress, on eBay, that is usable on transformers. And one of these transformers is this one. It's a perfect transformer, push-pull transformer, that can boost from 12 or 24 volts, depending on which kind of transformer you take, up to 380 volts, square wave, of course, yeah. But you can use it as it was intended from the Chinese too, to rectify it and make a DC voltage of that. And this is exactly what will happen in my next designs that I will be making for the tube power supplies. Some videos ago, I introduced the concept that I plan to use for my modular tube power supply, vacuum tube power supply, that will go up to almost 800 volts with the plus B, with the anode voltage, and up to 500, 600 watts. Well, this transformer delivers at least 500 watts, depending on the frequency, of course, you will use. So this is again an example how to use off-the-shelf parts, and make the designs repeatable and easier, much easier. So why I take this module and not just the transformer? You can buy the transformer online itself. Well, because the module costs, I think, $3 more than the transformer itself. So it's not a real gain. Yeah. This is why I'm taking the whole module. Perhaps I can use the MOSFETs too. These are Asian brand MOSFETs, so I'm quite sure there are no fakes. The rest is it's of no interest. Since I made in the last videos, I showed some small power supplies that go of higher voltages. For example, this one. This was one of the first ones that I played with, and I made my own version of that. Some viewers asked me, how can they make these things more noise-free? Noise-free is not the correct word. To have less noise at the output and to not need liquid nitrogen to cool it down. Well, it is possible, but you have to do changes on the design. Yeah. But even if you make it, a flyback is still a flyback. It will give you sharp edges and it will give you more noise than a push-pull. A nice design push-pull, yeah, transformer, power supply. So this thing, in its best case, will deliver 30 to 35 watts. Otherwise, even with the modifications, you need a massive cooling. I showed it in my previous video. For all the people that want to use off-the-shelf small power supplies in the size of this, I would suggest to use this one. Of course, you're dealing with absolute no current limiting, no nothing. Put a PTC if at the output of the transformer and at the input of the 12 volt. I would do both, yeah. And at the input I would use a normal fuse, and at the output, after the rectified voltage, I would use a PTC. That it is usable for the voltages you rectified, DC voltages. And if you say this is too expensive, too big, then okay, there's a smaller one. This thing theoretically will go up to 500, 600 watts here, depending on the frequency and on the design. But there are smaller ones that go to 100 and 150 watts. That's far superior than this one, yeah. And they are far cheaper. They're cheap, $5 or something like that, $6, not even. Again, you have the same problems with that, but they are smaller and cheaper. And you even have the rectification, with the diodes at least, that you need to make a DC voltage. And here you can choose the DC voltage with the jumpers. But anyway, I'm showing it again, how it looks, in case that somebody is interested to order it. just Google, or not Google, go to AliExpress and search inverter 100 watt or inverter 150 watt, and after a few hits you will see this thing here. And this is a inverter for 500 watts. Or look for this label, GZF-02-Y. Anyway, there are bigger ones than that too. One with a bigger transformer that goes up to 800 watts. But okay, today, the video for today is, wow, everything fall down. All the electrons are out now. Anyway, the reason, again, is this transformer. This transformer is, for me, very usable and will give me up to 800 volts, 750 volts with a full wave doubler at the output. And this is one of the designs, this is one of the basics I will use in my high voltage tube power supply. Of course, it will be completely current limited, protections, a lot of protections, short circuit protection, over temperature, over voltage, blah blah. Even the one that will deliver up to 500 or 600 watts will have the option to be digitally controlled. The option here. It will be a dedicated PCB that you can use with that. So let's take a look of the schematic. So this is the schematic. It is not very complicated at all. The whole circuit relies on an SG3525 push-pull controller. It's a very old chip, 30 years, something like that. But it's used in a variety of designs. This or the TL494. In my design, I will use the TL494 or perhaps a newer one. I don't know. But at least it will be a TL494 that has two operational amplifiers, two air amplifiers included. To explain now how it works, nothing very complicated. The air amplifier is more or less disabled through this configuration here. It's not used. You use the CT and RT pins that are the C1 and R4 that are determining that are making the frequency, and the R3 is for the dead time control. The rest is just the 1 microfarad is just for a soft start, so you limit the inverse current at the start. This is more or less what is used here. And then you have the power part. The power part consists of two legs. It's a push-pull. Yeah? Two legs of MOSFETs, pairwise and parallel, as you see completely. And here are even the gates of the MOSFETs are in parallel, and are driven through a 4.7 ohm resistors out of from the outlets of the chips. Where is it? Yeah, here, out E and out B. The whole thing is running at 40 kilohertz, the oscillator. That means that each leg is working with 20 kilohertz. These are the MOSFETs that are used. Are from Hynix. Hynix? I don't remember now. It's an Asian brand, and they're very good and quite cheap. You can get them from LCSC, for example. Yeah. So, what else? Now, The only what else? Yeah, we have a snubber network. Let me show it to you. This is the snubber network here, resistor and capacitor. It's very crude, but at least it's there. Input buffer capacitor with a high value, 2.2 millifarads at 35 volts. The complete design is here, as you can see, in through hole. Nothing bad with that. Easy for people to repair it if something happens. This thing is even socketed. That's a luxury, yeah. And the transformer. And here you have again the same in the schematic. But as I said, the transformer is the big thing here, yeah. You have the primary with, here's the primary. The center and the two edges of the primary with many parallel windings. Sorry guys, the fan is blowing my design away because it's too hot here. And on the other side, you have the output, the high voltage, let's say so. You have here 220 and 370 volts. And you have additionally a second winding complete isolated from the higher voltage outputs with 18 volts. And this thing you can use for the secondary side for the isolation, to powering the isolation components. You will see what I mean when I finish with the design. So this is how it looks. There are many different, or quite few different sizes from that. You see what I mean? It's the same transformer, but the height of that is, from this it's 15 and that's 20. This is quite a lot more powerful than this one, of course, yeah? So if this would be 500, it will be 600 perhaps, yeah? Or something like that, yeah? These are just numbers that I'm saying. The rest, it's the same. And of course you have other designs too that have just these outputs, 0, 258 and 300 volts. Again, usable, but if you use it just with the rectification, you get maximum 300 volts, yeah? I will use it with a doubler and you will get 600 volts. And I will show you again in a jiffy. So, let me show you how a doubler would look. It's very easy. It's not a big thing, but this design, what you see here, it's used in all the Chinese power supplies, Switchmode power supplies, that have the ability to work either with 110 or 220. They are not universal input because they don't have a PFC boost circuit in front of it that takes whatever voltage you give it from 95 up to 240 and makes 300 volts or 300 or 400 volts out of it. So this is the poor man's solution that was used way back in the day. Quite easy. You have the input that is either 220 from the mains or from the inverter output here. Rectify it, and then you have two capacitors in series and one switch. If the switch is open, these are in series and are just a full wave rectification. This would be, for example, in the power supplies if you use it with 220 volts. If you would use it in the power supply at the input with 110, you need to close this switch. Then the whole thing acts as a doubler, a full wave doubler. And this is exactly what I'm going to use with or without that switch here. It is very easy. With a doubler, you get almost 700 volts out, depending, then the current is depending on this on these two capacitors, for example. If they're calculated correctly, you can get the 500 watts out of it. The rest are just bleeder resistors, nothing else. So this is, and I will show you that again in a minute. Just for information, this is a switchable full wave rectifier to full wave doubler would look. So, took a while, not for you, but for me. And now we have connected the output of this module, nothing is getting warm here, to the rectifier board, just a full wave rectifier board with hyper fast silicon diodes with a very low TRR, reverse recovery time from, I think 40 nanoseconds, yeah, because you need that with this high frequency AC that comes in. And I'm using the 220 volt output of that because I do not want to overload my scope with, because it's a 1 to 10 probe, and yeah, I don't, to show you how it looks, it's good with that too. So these are 220 volts at the output, and this is how it looks. Again, I have to turn that off. You see? We are operating at 20 kilohertz and we have 220 volts. And at the moment, it is just my trusty load. Wait, I will take the camera off to show it to you better. Like that. I'm not overloading it. Let's make 30 milliamps, yeah. I don't want to go too high because I have no heatsink on the MOSFETs, but nothing is getting hot yet. Interesting, yeah. Nothing is getting hot yet. As you see, 220 volts. Let's go to 50 milliamps. This thing goes way higher, of course, but I don't want to go higher at the moment without any heatsink. So nothing is getting warm here. And we can see we are still at 20 kilohertz, 220 volts. I forgot to turn the lights on. Yeah, that's 50 milliamps. Just to show you how it's possible. I can go a little higher. That's 250 milliamps and still 220. But I'm getting back because I will overload the MOSFETs. This is 2.56 amps primary current drawn from the MOSFETs when it is 250 milliamps. But absolutely nothing is getting warm here. Nothing at all. And this is the output. Normal square wave output of a push-pull transformer, and it's quite so it's better. It's quite nice too. No distortions, no too much ringing, no nothing. They're not so bad, this motor, and the transformers are more. The most important is that these transformers are not bad at all here. So let me show you now how it will look with a doubler. So look what changed. Not much. just a connection from this terminal to this terminal. And this simulates exactly the switch. Now the switch is closed and we have a full wave doubler, as you see here. And look what we have, 470 volts. 50 milliamps, we're still at 440. 20 kilohertz, still 220 volts at the output. Of course, now that we are drawing 50 milliamps with a doubler, the primary voltage is doubled, the primary current is doubled to 1.1 amps. If it is in a full wave rectification, it is the half of it. It's more or less 600 milliamps or something like that, yeah. Nothing is getting warm. And this is how the doubler works. And this is how I will use these transformers with a doubler. By the way, I think you already have seen many times my DIY high voltage 200 watt load. Anyone that wants to build it, I can give you the design files. Just send me an email or write me, or even better, write me on the comments with a request. Yeah, this is exactly this schematic here, nothing else. So, what you say? These modules are not that bad if you know how to use it and if you know the restrictions you have with that. No current limiting at all. One short circuit and these four are adios amigos, are gone. Yeah? But okay, you can do something against that. Just put a PTC or a fast acting fuse. They are. Of course you can do it electronically, but for somebody that wants just to use this module as it is, without too many external gimmicks, rectification, or even doubling. Of course, these are small caps. These are just to show, it's just for a proof of concept, yeah. These are not the caps that will be at the end design, not even close, yeah. The final design will have filtering, everything. I want to go for a noise, output noise under 10 millivolts, yeah, at the full 700 volts. Let's see if I can make it. I think so. Okay, this is what I wanted to show you today. Again, El Cheapo module that many people think it's crap. You can use it, yeah, if you know the restrictions, the constraints that you have with that, yeah. But if this thing is too big, too large for somebody that has, for example, an audio tube preamplifier or a small amplifier with an EL84 or something like that, it doesn't need a 500 watt power supply, in the hundreds watt power supply. Guys, there's this too. This is exactly the same that you see here. Same with that. Two MOSFETs, but in a smaller factor. All the pros and cons as the other one. I just removed the transformer. Because as I said, for me, these modules are the source for scavenging the transformers. Because the modules, even more the smaller transformers, are more expensive than the modules themselves. So I'm buying the module and getting the transformer. And I have a couple of MOSFETs too. Yeah, anyway. So, that's for today. If you like what you see, Again, if you like my videos, please give me a thumb up. Consider subscribing to my channels. Guys, most of my viewers are non-subscribers, 75%. Please, if it would be possible, subscribe. It doesn't cost anything. It just helps me to continue going and to give you interesting content, even for such modules that many people will not even touch it. I will show you informations, designs, reverse engineering, and what you can do with it, tips. So, please subscribe my channel, press the notification button to get informed when I upload new videos. Give me a thumbs up. And now I want to show you how this transformer looks. This is how the transformer looks. It is a very nice and powerful core. It is not an EE core, it is an EC42 core with these dimensions. And as I mentioned before, the width of this core is normally 15. This is an EE42/21/15. It's this dimension of the one part of the core. The more powerful one that I showed you is the EE42/21/20. These are 5 millimeters higher, even more powerful. The same bobbin, quite nice. This is the horizontal version, and this is the vertical version. Unfortunately, I didn't find any modules yet with the vertical version, because I would prefer the vertical version. It takes less space. But who knows, if I find either this transformer in an acceptable price or the module itself, I will use the vertical one. So that's for today. Thank you for watching, guys. Wish you nice warm days. Drink a lot, and not only whiskey. Some cold things, some cold coffee, iced tea. I love all of that. And see you next time. Cheers. Bye and thank you.